All right, everybody. So we're looking at our trig graphs again. I know I just this might have been felt unfair to have you walk in and try them again, but I'm just trying to get a little bit of practice with these so you understand what's going on. Hopefully, you understand what the different tick marks are. We've got pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6. And then pi, and then 7 pi over 6, and 4 pi over, no, not 4 pi over 3, that's the next one. Get rid of that. Let's see here. We got 5 pi over 4, and then 4 pi over 3, and then 3 pi over 2. Let's see, the next one is going to be, now we're back into the pi over 3s. So we're at 5 pi over 3, 7 pi over 4, and 11 pi over 6, and you make it all the way back to 2 pi. Okay, I'm not going to write those down for each one to save time for this video, but I want to just kind of talk about the basics. So if I'm doing y equals sine x, we talked about that the numbers that we needed to know, the decimal approximations, obviously -1 is -1, and 1 is 1, and 1/2 is 0.5. But we said, well, you need to know that the square root of 2 over 2 was about 0.71, and the square root of 3 over 2 was about 0.86, almost 0.9. Okay, so that gives me something to graph for these. So I know that pi over, if I do y equals sine x, I know that pi over 6 is at 1/2. Pi over 4 is at that square root of 2 over 2, which is just shy of 3/4. And pi over 3 is going to be just shy, it's going to be probably right around here. And then pi over 2 is all the way up to 1. And then those points just kind of keep repeating here on out. Okay, and all the way down to the origin. And then we go down to the negative, okay, of the same thing. Let's see here. It looks something like that. Let's see, a little bit back here, and then there. Okay, and so your sine graph should look like this. You should be able to graph the points, and when I take the time to graph the points, I can really get a much better drawing, because it gives me something to shoot for, okay? And so that's what you should have for your y equals sine x. We can see that the amplitude is 1, it goes all the way up to 1, it goes all the way down to -1. We can see that the period is 2 pi. Okay, let's try y equals cosine x. Again, we need those same decimal approximations, but we know that y equals cosine x starts above the origin, and it ends up there too. It ends up above the axis. Halfway between, it hits that low point right here, and halfway between those, it crosses through the axis. And then I know, okay, so those are the easy points, the -1s, the 1s, and the 0s. But then I go, okay, right here, it's at that square root of 3 over 2, which is about here. Square root of 2 over 2, which is about here, and then 1/2. And then you do the same thing, but the other way. Right here, and here, here, here. Okay, and so that's what your y equals cosine x should look like. Hopefully it looks something like that. All right, so let's see here. Okay, and that's what I have for y equals cosine x. Again, you can see that the amplitude is 1 and that the period is 2 pi if I had that labeled correctly. Okay, now let's think about tangent and cotangent, okay? So tangent, the values that we see for y equals tangent x, well, we see 1 over square root of 3, which is about 0.57. We see 1, which of course is 1. We see the square root of 3, which is about 1.71, or just a little bit over 1.7. And that's really it. And then from there, we see undefined, which is where things kind of go crazy and they go vertical. Okay, and so we think through this. We go, well, all right, at pi over 6, I know that my tangent value is somewhere right about here. And I'm going to double check that one, make sure I got that right. 3, yeah, about 0.58. Okay, so it's just over 0.5. And then 1.73 for this one. Okay, we jump up to 1 at the 45 at the pi over 4. And then at pi over 3, we jump up to 1.73, just right there, almost at that 1 3/4 mark. And then we know that it's undefined right here. at pi over 2. And if you're not sure why it's undefined, it's because at pi over 2, cosine x is 0. And since tangent is sine divided by cosine, we can't divide by 0. So that's when it kind of freaks out. And so it should look something like this. It should kind of come up through here and kind of keep working its way up. Okay, this is not a great graph. Let's try that one more time. It looks something like that. It would keep going up. Okay, so then I keep moving on, and I see that the next points would be down here. For 2 pi over 3, we'd be down here at that negative 1.73, and then at negative 1, and then about negative 0.58, and then at 0. And it would look something like this. Okay, and it forever gets closer and closer to that asymptote without ever quite getting there. And after this point, what we see is we actually see the same thing repeat. Okay, we've got an asymptote right here, and this thing just repeats and does exactly what we saw over here, is what shows up here. And so that shows us, because this point right here is pi, that shows us that the period of tangent is pi. All right, we should be able to come up with a graph of cotangent pretty similarly. But we realize that cotangent is going to be undefined where sine is 0. And so the asymptotes are going to kind of be shifted a little bit. They're going to be at 0 and at pi and at 2 pi. Okay, we know that it hits 0 right here. And part of the things I'm thinking about is I'm thinking about this graph right here. Whenever this hits 0, that's when I'm going to have those undefined points. Okay, and then I think about if it's cotangent, whenever this hits 0, that's when cotangent is 0. And so that's right here. Cotangent is 0 at that spot. Okay, and so for cotangent, the other way of looking at it is it's the reciprocal of tangent. And so we said when we have a fraction and the denominator is really small, that the overall value is huge. And that when we have a fraction and the denominator starts to get big, the overall value is really small. And so this thing's going to be kind of like a flipped version, okay? And so again, we can start with those values. We know it's got 0.58, we know it's got 1, and we know it's got 1.73, which is about here. And so this really, it kind of looks like this. It starts really high, and it comes down, pushes through the axis, and then we're going to see what? Negative 0.58. And then negative 1, and then negative 1.73. And so it's going to look something like, come on down, and look like that. Okay? And it's going to repeat. Now, I don't love what I did here at the end, because I don't want to make it look like it keeps slanting. It gets forever and ever closer to that asymptote, but never gets there. Same thing with on the bottom side. It gets forever closer to that asymptote, but never gets there. It doesn't curl away from it. Okay? So that's what cotangent should look like. And we would see another one of these repeated right here. Looking right there. That's terrible. Okay. Now let's talk about secant and cosecant. So for secant, I'm going to go to my cosine, okay, because I know that secant is the reciprocal of cosine. And so now I need to think about what are those decimal approximations. Again, now I got to think about all the inversion. 1 inverted is just 1. 1/2 inverted is 2. Square root of 2 over 2 inverted is actually square root of 2, which then is about 1.41. And square root of 3 divided by 2 inverted, hang on, let's see, divided by 2, what do I get? Is about, hang on, there we go. It's about 1.15, all right? And so 2 divided by square root of 3 is about 1.15. 2 divided by square root of 3 is about 1.15. So this shows you some of the values that we're going to see here. Now, if this is the reciprocal of cosine, then wherever cosine has a 0, it's going to have an asymptote. So it's going to have an asymptote right there and right there. It's going to hit this point because the reciprocal of 1 is 1, but then the reciprocal of this square root of 3 over 2 is just above 1, 1.15. The reciprocal of square root of 2 over 2 is square root of 2, so that's right here, what, 1.41. And then the reciprocal of 1/2 is 2, and that's up here. So this thing kind of starts pretty flat, and then again, it explodes up kind of like tangent and cotangent. And the same thing happens here, all right? And so maybe I should change color so we can see the difference of these two. So here's secant right here, and then on the underside, it would be here. It would be just below 1 or -1. It would be about, 1.41, so that's going to be just shy of -1.5. And then it goes all the way down to -2. And so it looks something like this and kind of gets closer. And the other side looks similarly, okay? For the sake of time, I'm going to move it along a little bit quicker. And it almost looks like a parabola. Here, we would pass through this point, here, here, and then all the way to 2. So it would look like that, okay? And so that's what secant looks like. And then for cosecant, you'd go, well, it's going to have an asymptote wherever sine equals 0. So there's going to be an asymptote there. There's an asymptote right here. And there's going to be an asymptote right here. Okay? It hits this value. The reciprocal of the square root of 3/2 is just bigger than 1. So it's going to have these values right here. And then we know this one is almost 1.5. So it's right there and there. And then we go all the way up to 2 for here and here. And so again, we can see this thing. It almost looks like a parabola. Kind of spikes up like that. And looks like that. And then down here would be the same way. Okay? And so my expectation of everybody in this class is that you can come up with something pretty similar to this if I ask you to graph any of the 6 trig functions. That you should be able to kind of go, yep, and definitely you should be able to identify them. If I show you the picture of a graph, you should be able to identify them. So this one right here is y equals cosecant x. And this one right here is y equals secant x. Okay, hopefully that made some sense, and hopefully yours looked just like mine. And now you're going to get to watch another video.